Hi and welcome to the session on modern enterprise Java from the ground up. And yeah, I'm very happy to talk about this topic here from modern enterprise Java, whether there is such a thing. So my name is Sebastian. I'm born and raised in Munich, Germany, and I work for this company called IBM. And I have a lot of background in Java in general, enterprise Java in particular, and enterprise software. So I've been a consultant and doing a lot of things there. And what I want to show you in this talk and what the motivation is basically to somewhat show you a restart for things related to enterprise Java, for if you heard of J2EE, of Java EE and all that story, to show you how modern enterprise projects for cloud-native microservices are being built up from scratch. So if you have already a history in things related to J2EE or Java EE, you might as well forget a lot of things because there's a lot of history involved right there. And what I want to show you is a modern approach, best practices, how to do that. And I don't know about you, but I think slides are mostly kind of boring. So I will show mostly live coding and live demos because I think that's just more interesting to watch. And especially after lunch, if I would tell you the story how we came here with now Jakarta EE and things like that, you would immediately fall asleep. So I don't want to bore you with that. What I want to show you is just two things that you might heard of, two technologies. And I'm going to actually use them both. One is called Jakarta EE. Sounds very much like Java EE, and that is actually the successor of Java EE. So now Jakarta is open source under an open source foundation, under the Eclipse Foundation. And the most important thing is Java EE or Jakarta EE, you could replace that. What I want to focus on are the quote-unquote good parts, at least according to me. These are the technologies that you want to care about. Why? Because Java EE or Jakarta EE traditionally includes a lot of things because of a long history. So there are many technologies that you certainly don't want to use or don't want to look at because of everything that is being supported out of being backwards compatible. But what we do want to look at, here's a small list of that. CDI, you might have heard of this, very powerful technology for injection and for building up components. JAX REST, we're going to have a look at that. RESTful Web Services, how to use it, JSON-P, JSON-B. I'm pretty sure you're familiar with these terms. JPA, JTA for transactions. EJB, but only in the latest version, version 3, not the old stuff. So EJB includes some somewhat reasonable technology that is still useful, and then a few other things. Now, the second thing that I will use and show you is technology called Eclipse MicroProfile, which I will use as somewhat an extension for modern cloud-native based workloads and, technology that is needed there. So the good parts of MicroProfile, and the interesting thing is it's actually based on the same technology, so it's very much related, is that it comes with a few more technologies that are helpful for us. If we think of traditional enterprise systems, we might miss a few things like, for example, metrics, how to build fault tolerance, and a few APIs that just make our life simpler. So I'm going to use some stuff right there. And other than that, let's just start right away. And I'm going to show you a few best practices that you might have seen or might have not seen. So for example, this is a Maven project. Who of you uses Maven to build enterprise projects? Most of you, I would assume, yes. And that part is already quite important because I care a lot of keeping that simple as a best practice. There are a lot of Maven conventions out there that can be used right away that most developers even aware of. So they would redefine things and redefine plugin structures and configuration that's actually not needed because Maven does a lot of things very correctly, very well, just out of the box without changing anything. So what I will use, I use thin deployment artifacts, and there's a reason for that I will tell you a little bit later. And I will use just two dependencies. One is called Jakarta, that's the modern Jakarta E8, and one is called Eclipse MicroProfile. That's it. Important thing that you see here, provided scope for these dependencies. So that means they don't end up in whatever you're building, right? They don't end up in the deployment artifact. And everything else you see there is actually just test thing. So that's already an important thing. I don't want to include, stuff that I don't really want to have in my application. Only what's required, only these provided dependencies. Everything else is just there for test purposes. And then what I have is the configuration of my Java build. I use Java 12 just because I'm brave. So it's not even the latest one. Java 13 would be, latest version, right? So I could update that. That is also a thing. Other than that, I don't use any, plugins or configuration here. This is just redefine some versions, and that's about it, right? And then the application is called Coffee Shop, just because I like coffee. And what I will show you is just real quick a walkthrough through the Jakarta application I have here, which we then gonna live code and enhance a little bit. So imagine I want to build up an application where I can order some coffee, right? It's after lunch at a conference, you want to place an order for coffee, right? And that means, well, we're going to build an application that we can communicate with via REST. So you probably have seen that code, these APIs. This is called orders resource. That is going to be an HTTP resource and REST resource, if you want. That is accessible via some URL path /orders and communicates with, well, resources that are represented as JSON, right? So I could, for example, issue some HTTP GET to get some orders, right? Or some POST to post some orders, to order some coffee, which already uses quite some enterprise APIs. So the nice story about that is it's very declarative here. I just write some Java code, right? And then I sprinkle some annotations on it. And that already makes a lot of things happen, right? So that is going to be an HTTP handler with a POST request being coming into the system. And this is being ended up in that method. And then I have some Java class, just a coffee order, which just because it's defined within a JAX REST resource will be deserialized from JSON. And this is just my business component, a coffee order with some, that's the order that I place. I can order some different coffees like, espresso, latte, or whatever. And well, that's pretty much it. And then I have a business component that I call Coffee Shop that just, well, talks to the backend that stores the coffee order for me in memory. Okay, whatever. And that's pretty much it for that use case. So that creates some coffee. Okay, now enough talking. Let's see this in action. Let's see what that does. And now for the best practice of building this project. How would I build this? First of all, that's a Maven project. So I will build this using Maven. And I call Maven clean package, or I could also call just Maven package to build this. And now the first important thing is this has to build real quick. So, well, that's too slow. Let's do this again. Maybe the computer is under load. 4 seconds or less, 2-3 seconds, that would be ideal. Well, anyway, but at least fast enough, to build your project in a modern way. Any plugin configuration you add or any sophisticated test cycles just makes it unnecessarily slow. We will talk about tests a little bit in a second. But that is important that it already builds things very quickly. Another thing is because of these thin deployment artifacts, our WAR file that we produce is tiny, right? It only contains the classes. We can have a look. The classes that we include, that we compile, the classes that are part of our project, nothing else. Why? Because our enterprise runtime includes the implementation. We don't ship an implementation and we don't build the implementation into a binary. Because also, I believe it doesn't really make sense because we have to build this binary many times a day. And each time 99% of the code that we ship wouldn't change, right? So we want to separate the implementation from our business logic. So in this case, we have now a thin deployment artifact that we could target, that we could deploy. So now if you know about traditional EE runtimes, we could go and download some runtime from some website or whatever. Or in this case, I use Docker containers. So I will deploy this later on in a Docker approach. Docker files, you probably have seen these. That's also very interesting already how we can build up a best practice for Docker files or for creating Docker images. I built this thin deployment artifact, this WAR file, for a reason. First of all, it's fast to build. My Maven build is real quick because I don't have to copy a lot of megabytes around. And it really makes sense for that Docker approach. Why? Docker comes with a few enhancements, a few optimizations on the caching level. It's being built on what is called a copy on write file system, and it only, well, points, it references to changes in, well, the file system, to diffs, pretty much like Git works, and it will only apply these changes and transfer changes that actually have been made, right? So for example, that means if this base image contains a lot of, megabytes of stuff, and these two files are very tiny, then each and every time I transmit something, the changes are actually tiny as well. I don't transfer a lot of things, because most of it might already be existent, on the other machine. I can show you this in action in a second. So the whole thing I built with my Docker image is, well, everything that my application needs in order to live, in order to run. So in this case, I include some runtime, OpenLiberty. I can show you this on the website as well. That is an open source runtime that is originally based on WebSphere Liberty. Has been open source. There's a commercial support available for that. And this is what I use together with Java 12 to run my software. Okay. And then I will have some tiny configuration as well. And then I built this for my coffee shop. Okay. Enough talking. Let's finally do this. Docker build. Let's call this coffee shop. Build this application. Again, is tiny for all the changes that I make, and it builds fast. So then we can run this locally. Docker run 9080 coffee shop, right? Or how did I call it? Coffee shop temp? No, coffee shop. Let's call this with a name. That's also best practice for Docker. Always put in labels, coffee shop temp, right? Coffee shop temp, run this. And while this is running, I can show you another thing. So if I just built my, image, I can do this again, built with actually a Docker Hub name, coffee shop temp. Why? Because then I can Docker push and pull my image, and now depending on the network, what you will see, I now will do a Docker push, which is an image that has, hundreds of megabytes, I think 400 and something, including the runtime, including the JDK. But even over a somewhat okay-ish conference network, it's doable. Why? You saw it actually only pushed a few kilobytes. Why? Because the diff is tiny. The diff, my Java classes that are included in my WAR file, is very, very small. And each and every time I make a new build and I ship this Docker image, it's a tiny change. It's just kilobyte that I transmit. And I kid you not, I used my phone tethering somewhere in the middle of nowhere, and I used an airplane Wi-Fi to push Docker containers, Docker images before. If you have such an approach, it works, right? You're just pushing a few kilobytes, which is not a big deal. So that works here. There's a very nice approach for that. It just leverages that principle. And now finally we can have a look at this coffee shop example, coffee shop / orders. Coffee shop is the name of the application. And then we can HTTP get the list of coffee orders, which is, well, an empty JSON array, right? So there is no order in the system. That's not really surprising. But now let's finally create some order, right? We want to see this in action. Okay, what we do, we're gonna post some JSON to this resource, right? This is what you saw in the code. We actually want to post a coffee order here in the JSON representation. So how does this look? Well, we need at least the type for the coffee order, which, let's say I want to order an espresso, if that's all right. And then, well, hopefully, if we're lucky, that's good news. 201 created, the order has been created in the system, and I can actually now have a look at the list of my coffee orders, and I will see, okay, great, there's an espresso there. Good, works. Okay, that's actually not what I wanted to show you. That is just, a nicer Hello World example of a JSON response that I posted here. But now what I can do, I can change some things, and I especially want to introduce some, MicroProfile APIs. So I want to introduce, a few APIs that are required for modern runtimes. So that is already that is already something that I can run in, a Docker container. I can run this and rerun this now locally, and, in order to perform some actions here. Now what I will do, I will actually change some stuff and live code something here, and then what I would need to do. So, who of you attended my previous session earlier today? Of you? Okay, that's good. Not too many, because then I don't spoil too much. What I was using there already was an approach to make these changes a little bit faster. So, assuming I change some code here, what would I need to do in order to reflect the changes? Well, I would need to rebuild my project, right, using Maven, what I did before, and at least rebuild the Docker image, right, Docker build. And then I would need to restart my Docker container, right, Docker run, because I cannot hot swap running containers. I need to start that again, and then I have the changes being reflected. What else I can do? What I will show you here is an approach that actually runs Maven with Liberty with a plugin that allows me for a more sophisticated development workflow. So now this sounds like it's a little bit against the principle that I say keep the Maven workflow as simple as possible, but at least this plugin doesn't add anything to the normal build. If I say Maven package, it's actually not executed. That's a good thing because I want to keep my Maven build simple. But if I say liberty :dev, what I just called here, then what it will do, it will start up a development mode of my OpenLiberty runtime, which is a little bit different to what I would run in my Docker image, but it comes with a nice feature that it actually allows me to change things on the fly and add code and change code and apply that immediately. So what does it mean? I now curl, let's call this again. I now redeployed my application, so I can call it again. I get my coffee orders, now it's empty. Okay, fine. I could create some coffee orders, now I have an order in the system again, so it works, right? It's the same application that has been deployed. But now I can add some more features. And what I will show you is, let's start with health checks. I will show you a MicroProfile API, MicroProfile Health, which allows me to add, well, some health checks. And what MicroProfile does, it just adds some APIs of, well, features and concerns we need for modern microservices that we then don't have to code ourselves, right? So if, for example, I want to add some health check endpoint, then I would need to write some JAX-RS class or whatever. And what I can do here, I can just add some health checking here, which is an API that now you see it in the package. It comes from MicroProfile, MicroProfile Health, okay? The nice story is that API isn't compatible with, with Java Enterprise. So what I can do, call this coffee shop, I now add a health check for my application that just, it's very simple. It just says yes. As soon as the application is deployed and so-called ready, it will add this CDI component and then says, okay, I'm ready. You could add all kinds of custom checks here. You can say, please check the database, check an external system, whether my application is up and running, and then it will just tell you. Now, the nice thing is, I could now restart my application and show you how that works, and then you would see that under curl localhost /health, I see something available. This /health is, by the way, a convention by MicroProfile Health, so it will show you, oh, once that is, let's see this. Oh, I need to activate it, sorry. Once that is the case, it might show you some stuff here. So what I can do, this is, let's remove this for a second. This is my server configuration in XML for the OpenLiberty, but don't worry, it doesn't get much bigger than that. It includes the feature that I want to include in my runtime. And that is already an optimization. I could say, please include the whole of Java EE, include everything in MicroProfile. But why I list the features individually is just an optimization that it loads faster, right? Because it loads less stuff. And what I can add here is I can add MicroProfile Health. And that is already a feature of this plugin that is running. It actually will inspect the features that I need in, what's going on here? Now it works. In my application. And then it will hot reload whatever I have in my code. And now it just added the /health endpoint for the health check because I added this health check component, and then it will says, oh, now I have a new check here. It says coffee shop and it's up and running. Now I have two features available here. First of all, I can add runtime features on the fly. And the second, much more interesting, I can actually add code and change code here on the fly. So for example, I can say, in my health check, please add some data. Hello world or hello Uridev, right? What it will do, it will hot reload my application and immediately see the changes in my code in general, in the whole application. So this is specific to that feature that I just added. But what it will do, it will very quickly in less than half a second or at least less than a second update the application with just, well, compiling that class and swapping the class in the running process. So for me, it's very, very fast to just, change some stuff in my application while I'm coding. This is really, really efficient. All right, but what I actually want to show you is some features in MicroProfile. So that was MicroProfile Health Check, which is an API to do some health checking that then you would use for your Docker containers, or if you use Kubernetes. I can show you that in a second as well. It's helpful to easily add health checks here. Something else, config, injectable configuration. There is MicroProfile config that is also shipped with MicroProfile that I can use here as well, because my runtime supports that. I can use this annotation at config property, and then, for example, say, oh, please annotate and inject a configuration that you find by some key, by some configuration key. For example, version. So I can say, not short, but string. Include a string version, for example, and then add this version to my health check here. Version. All right. And then in this case, I will output and emit this version as a config here as well. And once that is up and running, of course, what did I forget? Forgot to add the feature. And again, this is just an optimization. I could say, please add everything in MicroProfile, and that would be simpler. But this then, starts up a little bit faster. So in this case, now it will redeploy my application. Probably installing a feature here that I can use. I can also have a programmatic lookup of the configuration, depending on what you do in the code, right? Not just the declarative approach of injecting it here, but also, a more sophisticated approach. For that, let's live code a little bit more. Assuming we have our coffee order. Do we have some order in the system? Let's have a look. No, let's create some. Let's add some more information for the order. The coffee order here comes with a few things like, a coffee type, espresso, a status. Let's add some price, right? Let's add some price here. Assuming we have our coffee order, where is it? We want to add some pricing information. So assuming we have a status, and then we add some private, double price. By the way, never use floating points in real life to reflect price information, right? Don't do this at home. And let's add some getters and setters. Oops. For the price. So let's include the price in the coffee order. And then, of course, the user should not specify the price, right? That should be specified by the configuration, obviously. So what we're going to do is we're going to deploy this example with our business component to say, OK, now let's update here something in the price. And I want to have a price calculator. So I'm just writing a new class, price calculator, that is going to calculate the price. So let's say we have something like public double calculate price for a coffee order, right? Something like this. And then now, depending on the order type, I want to calculate a price. And probably you have already seen, want to calculate that price. I don't know which currency I used here as an example, so this will be a little bit expensive. And should we do the Swedish krona, right, for a coffee? I don't know. I heard Sweden is expensive in general, but that would be a little bit crazy. So anyway, we can change that. But that means we want to look up the price depending on the order type, right? So depending on the coffee type, of course, we want to say, for example, return and then get configured price, something like this, for the type, which then will be, implemented here. And now that is the programmatic lookup we can have. For example, we can have a look at the config provider. We can say, oh, now please give me the config, and now do something like, give me a value for a specific key, right? And then the key will be, for example, computed on the fly. So we have something like coffee.prices. Type of it, right? So let's say coffee.prices. The type of the name to lowercase, something like this, right? So let's have this, and let's look up. The type should be a double, right? So I'm assuming that is correct. Now this is all done programmatically. It's not that convenient as doing the injection part, but now it's of course much more flexible and powerful. I can inject the configuration here. I can even say get some optional value if it's not available, have some default, and so on and so forth. But now I can already use this component. So what I would do, of course, I would inject my price calculator, right? So, and use this down there. So let's say order set price to, well, whatever I calculate here, right? Calculate price for the order. By the way, I'm relying on you that I don't make any mistakes. Is it correct? Yes? No? Maybe? Yes? Okay, perfect. Somebody believes in what I do. Let's redeploy this and then see whether it works. So order, well, it's empty. Let's create some espresso. So coffee has been created, right? Great. And now let's have a look whether that works with curl. And it says, oh, great. It's now, well, way too expensive, right? That is an espresso for 80 krona. Okay, let's change this a little bit. That is too crazy. Now help me. What is a good price for an espresso? 20. I think outside there's a coffee shop and they had like 25 or something like that, which I think is a reasonable price. Let's make the other ones 25 and the espresso 20. I think that's a good price. And then again, you saw the configuration will also reload, so we can do this. And let's now order some latte in the newly deployed application, and the latte should, yes, now be 25 krona. That's a little bit more reasonable. Okay, then we get our reasonably priced latte once we reload that, right? So that is a feature to show MicroProfile config on a programmatic approach. We can do the programmatic lookup of our config sources and then inject these values. This is just, much more convenient than coding that ourselves, right? Because before this MicroProfile config, what we had to do, we had to use CDI features to, for example, use, something like a CDI producer method, and then doing the lookup in the property file ourselves. It's not rocket science, it's like a few lines of code to read from the property file or from an environment variable, but it's just much more effort than if you do it yourself. Another feature, which is a little bit more helpful if, for example, you have some monitoring, let's have a look at MicroProfile metrics. So MicroProfile metrics, what that includes are some metrics out of the box. So for example, MicroProfile metrics 2.0. include, well, some technical metrics for my application that might already be interesting. So under the path / metrics, I will find some metrics that I typically, well, my OpenLiberty says these metrics are actually not for everybody, so I will just, make them only accessible via HTTP. Where is it? Forbidden. And then, I would need to use HTTPS, or I just say, MP metrics authentication false, because now for my debug example I really don't care. False if I can type, and then I can have the same thing again. It will just read the configuration and reload, and now this looks a little bit weird. This is a plain text format that is called Prometheus, the Prometheus metrics format that, well, will be scraped in a cloud native example in my Kubernetes cluster via Prometheus instance, which then Prometheus is a time series database, which then will be stored in a time series database and can be, displayed in some fancy dashboards. And then I see, the memory consumption or some JVM details here. What is the memory? What is the CPU? Garbage collection, and all kinds of things that I could display. Okay, this might be helpful for operations. So it already includes a lot of things out of the box that I don't have to configure, which is good. But these metrics are particularly interesting if I can include some business-related metrics, right? So rather than just saying, what is the transaction rate, what is the memory, whatever of my application, I want to say, okay, how many orders have been placed? How many coffee was ordered? How many, how much money did we earn today? How much revenue we have, or whatever. So what I also can do, I can use this metrics API for, as an API in Java code. I can add my own custom metrics, right? I can say, please add a counter for all the coffee orders and then calculate the price or something like that per day, right? And emit that as well, which from a business perspective is, of course, much more valuable. So for example, what I could say, in my business component coffee shop, I could, let's say, inject some metric that I then programmatically, modify. So I say, now we just got some order, now please increase it by the coffee price or whatever. Or in this case, there are many examples available. I could either programmatically inject a metric, or I do, that's the simplest example, I annotate a method with @counted that literally, counts the method invocations. So in this case, that's quite straightforward. I could say I just count the number of ordered coffees, right? Which is already might be quite helpful. How many coffees have been ordered today? And now if I redeploy this, then I'd say, for example, I want to post and create some new coffee. 1, 2, 3. And then I go back to my metric and say, oh great, now I have a new counter being included in this example, and that is already showing me 3 coffee, right? So that is there out of the box, it's included in that metrics, and it's very simple to use. I could inject my own counter and increase it. I could have a histogram and a gauge, some other types and things like that. What is included in this API? So again, just much more helpful than writing all of that yourself. And these are just a few examples where it helps you to have this combination of this MicroProfile APIs and more traditional Java EE. So you can have a look at that. There are many more examples that I could show you in that time. What else I would like to show you is just some example how that whole thing runs in a cloud environment. So what I have here is some Kubernetes example, right? So we want to order some coffee that actually runs in a more production-like setting. And you probably, Kubernetes, where's the website? Who of you is using Kubernetes or anything similar, like a container orchestration? Nobody. Oh, well, few. Yeah, at least. So maybe you had a look at this technology already, or that's especially from experience where most of the ecosystem is moving to, like to more these cloud environments. We have containers, we have containerized environments, and that is just the next step. A technology that orchestrates these workloads for us, right? It's just another way of using an open source technology for things we otherwise have to do ourselves, right? A lot of enterprises have written their own frameworks, their own technology, how to run stuff in production, right? How to run their VMs, how maybe to run containers, and that is just a more sophisticated set of proven open source technology. Originally developed by Google, has been open sourced many years ago, and what you can do, well, you can use a Kubernetes to basically run that in a, let's say, production or staging environment here. What I have, if the Wi-Fi works, I have a Kubernetes cluster that runs on the IBM Cloud Managed Kubernetes Service that, as you can see, now is empty. If you might have seen that before, kubectl is a command line tool to basically talk to my Kubernetes cluster. So it doesn't run any applications now. Control pods. Pods is a workload, like a running container, and it says, well, empty. What I can do, I can actually deploy something now, and what I just did is what I can show you, these YAML files. So you might have had a look at this. That is basically as code description how my environment should look like. So very similar to the idea what I had with Docker files. Docker files is an infrastructure as code example of how I want to define stuff in a declarative approach, right? I define the target state as code. I put that into the version control next to my source code. And this is now further specifying how the whole environment looks like, right? Not just one instance, but the whole services that I have. I have some load balancer service here for my coffee shop. I have my deployments, which is one version of the instance, so I could change that to 2 or 3. I could increase the number of instances, and now if I just take these files and apply them, throw them against my cluster, then it will automatically create some resources for me. So then when I say, oh, please, the target state should be 1 instance of my coffee shop, well, then it will go and take and deploy 1 instance of the coffee shop deployment, right? And that just runs my default Java EE plus MicroProfile application and runs that on the cloud. And it will include, and you make use of some health checking. So it will ask the health check, hey, are you already ready to serve some traffic and to do something meaningful? And now that is the case. Okay, great. Now I can go against my cluster and find out the IP address of my cluster and say, okay, where's my coffee shop orders? So same thing that I just had. And this is now using an actual IP address of my Kubernetes cluster of where I just deployed my application to. So you see that also enables me to just ship software so much faster by having some declarative approaches as code and then just roll them out as you go in a very sophisticated same way. Let's order some coffee here. That is basically being created on the cloud. Let's order some espresso, and now that is being created. Okay, great. Let's have a look. That is the created coffee order in my cloud environment that I just deployed to Kubernetes. And this is then a workflow where quite easily I can write some things. I can build my application using Maven. I can build my Docker images and then deploy it to, for example, an environment, which of course would be made as part of an CI/CD pipeline then. So as some key takeaways, the nice story about this combination of a modern enterprise Java is that we use known technologies and known APIs, known approaches, right? A lot of developers probably have used EE technologies at some point in their career, right? They probably know what Jakarta is, what CDI is, servlet technology. There's a lot of things out there, JPA for persistence. That all comes from enterprise Java, and that you can just continue to use in such a modern approach. And what I always would like to focus on is what solves business problems, right? That's the beauty of that approach. You code your business solution in Java. You code that in Java classes, right, as you always did. And then you just add some annotations, and that's basically the description what your runtime should do, and that's pretty much it, right? So it's not very heavy. It's literally just some few annotations, comment-like structures that add to your code that then you can use there. I think the combination of Jakarta and MicroProfile is really great for modern approaches there. So if you look into these technologies, there are some runtimes out there that support either Jakarta or MicroProfile. But I think for pragmatic real-world projects, it makes sense to use both technologies together. And OpenLiberty is one solution where you can use that in combination. Another solutions are Tom EE, for example, or Payara server or Wildfly. So these are all runtimes that support this approach, where you can just very quickly and very productively write applications, modern applications that solve your problems there. Also, it's quite interesting to have a look at that if you work for an environment that has existing investment in EE. Either if it's the knowledge of developers, who just know how to use CDI, Jakarta, it makes a lot of sense to just continue to use that, but please with a modern runtime, right? That's the whole point. Or you even have projects that were built originally for, for more legacy runtimes. If you have projects that have been built for an old WebSphere, for an old WebLogic and stuff like that, you definitely want to swap the runtime, right? Nobody wants to run that old crap that just takes half an hour to start up, right? So there are much more modern runtimes out there today, for example, OpenLiberty. But since it's based originally on the same APIs, on the same technology, there's a high chance that you can reuse most of it without, migrating too much, without rewriting everything from scratch, right? If you would choose a totally different technology, you migrate to a different language even or to a different enterprise framework, well, then you definitely have to rewrite everything from scratch, right? You have to throw away all the code you have because it's a different API. But with that approach, there's a high chance that even if you use some legacy stuff, it is still supported. And the same is true, of course, for the knowledge you have. That's actually much more important as a developer to use these APIs. Then what always helps is to keep the build simple. That's why I showed you such a simple Docker file, 3 lines of code, simple Maven approach without the plugin configuration and whatever. Use the conventions that are there. You might have a look at the documentation of the build tool convention of Maven phases and things like that. They are very straightforward, and you don't have to add a lot of XML or stuff like that if you keep that simple. And of course, invest in testing and automation and CI/CD. Well, that is always a good idea, right? And that just enables you to ship your software with more confidence and faster and with quality being built in. So I hope that was a helpful overview for a modern way how to build enterprise Java applications, and I hope it was fun to watch. Thank you very much for your attention.